This is 8.2, circles. A circle is the set of points in a plane whose distance from a fixed point in the plane is constant. So this one would be fixed, and constant goes here. So the set of points is also called locus, as you can tell, and if it's equidistant from the same point. The center of a circle is the point that is the same distance from every point on the circle. An arc is a curved line that is part of the circumference of a circle. A line segment within the circle that touches 2 points on the circle is called a chord, while the distance around the circle is known as the circumference. And the diameter is the longest distance from one side of the circle to the other. Now, pi is an irrational number. Sometimes you see it as just pi, like that. 3.141592, it goes on forever. That is equal to the ratio of the circumference and the diameter of any circle. Now, the distance from the center of the circle to any point on the circle is the radius. A sector is like a slice of pie. It's a circle wedge. And the tangent of a circle is the line perpendicular to the radius that touches only one point on the circle. So that's all our vocabulary. Now on the side here, notice we've got the visual vocabulary. So what we're going to do is draw pictures of all the things we just talked about. So first of all, there's your center. You can see that that is the center of the circle. If you have something going straight through the center all the way across, that would be your diameter. Let's see. A chord is just any 2 points on the circle, right? Connecting it. Doesn't have to be the diameter. Diameter is a special chord. Circumference is just your distance around the circle. I feel like y'all know that already. So distance around the circle. Let's see. If we have just a slice of the pie, let's say we have this, like that, then the area in here is called a sector. This is a sector, like a piece of pizza. An arc is just a portion of this, so like the distance from, say, here to there. See if I can clean that up a little bit. It looks kind of messy. Radius, let me just draw that this way. What if I just do, like, say, a radius this way, and then if there's one that's perpendicular and it touches it only one place, this is a tangent line. Okay, and this is radius. It's half a diameter, but I believe you know that already. So very, very little of this is probably new for you with circles. It's going to be one of the easier lessons of studying of conics. Okay, so this next page talks about the circle formulas, and it shows you the relationship between just the distance formula, which is your Pythagorean theorem, and the radius. Okay, so now we have our circle formulas. If the center is at the origin, then it's just x squared plus y squared equal to r squared. If it's at something other than the origin, it's x minus h squared plus y minus k squared equal r squared. The area remember area formula for a circle is pi r squared. Circumference is pi times the diameter, or sometimes you see it as 2 pi r. The diameter is equal to twice the radius, which you knew that already. Length of a circular arc, angle in degrees. Do you remember when we did trig and we had S equal r theta, and theta has to be in radians? That's the same thing here. Okay, S is like our sector. The area of, the length of the arc, S is equal to r theta. And then area of the sector would be capital S here. This would be theta divided by 360 degrees pi r squared. So it's basically taking the area formula and adapting it just for the sector. Okay, so example 1 and 2 have us writing equations of a circle. So in example 1, what is the equation of the circle with center at 5, -2, and a radius of 6? Well, if we're using our formula, then that is x minus h squared plus y minus k squared equal r squared. So this would be x minus 5 squared plus y minus -2, so I'm going to go ahead and put plus 2 here because you never want to leave minus a negative, and 6 squared would be 36. Example 2, what's the equation of a circle with a radius of 5 and the center located on the x-axis where x is equal to -3? Okay, so that ordered pair there would be, if it's on the x-axis, then y would have to be 0. So this would be x minus -3, so I'm going to go ahead and put x plus 3 squared, plus y minus 0 squared, so that's just y squared, equal to 5 squared, so that's 25. Very good. Okay, so next part, using translations to write an equation. So let's look at example 3. Write an equation for the translation of the circle, x squared plus y squared equal 4, by 3 units right, 2 units down. Sketch the original circle and the translated circle. Find the distance between the two centers. Okay, so the center of the first one is 0, 0. Okay, so I'm going to draw the first one. Radius is 2. So the initial one I'll do in blue here. Let's pretend it's actually a circle, y'all. It's kind of hard to do this. Okay, just do the best you can. It doesn't have to be perfect. Okay, there's my first one. So the next one I'm going to do in red. Okay, so from this center I'm going 3 units to the right, 1, 2, 3, and down 2. So that's my new center. So my new center would be 3, -2. So if I write my new equation, this is going to be x minus 3 squared plus y minus -2, so I'm going to go ahead and put plus 2, squared equal to 4. So that's the new equation. And if I draw this new circle, remember it's out 2, up, down, side to side here, 2. And I'm going to just draw it in a dashed line, even though I do have it in different colors, just to, oops, looks kind of off, but close enough. Okay, so there's my new circle, and now they want the distance between the two centers. Let me go to a different color. Okay, so the distance between these two. Well, if we use our distance between 0, 0 and 3, -2, then that's going to be, let's see, 3 minus 0 squared plus -2 minus 0 squared. So 9 plus 4. So that's the square root of 13 is the distance between the two centers. Okay, so example 4a says write the equation of the circle that passes through the point and has the center at 2, 1. Well, that's pretty straightforward because we have a center. So I know I've got x minus 2 squared plus y minus 1 squared. But the thing is, I don't know the r, the radius. Well, if this one's point is there, I know r would be equal to the distance between those 2 points. So 6 minus 2 squared plus 4 minus 1 squared. So that's 4 squared and 3 squared. That's 16 and 9. That's square root of 25. So the radius must be 5. So 5 squared is 25. All right, so let's look at part B. Write the equation of the line tangent to the circle at 6, 4. Alrighty, so we have the center of the circle is 2, 1. And it goes through 6, 4 also. Okay, so we need our slope. Anytime we write an equation of a line, we need slope. All right, slope is 3/4. Okay, so if we want the equation of the line tangent to the circle, then it's going to be perpendicular to that, remember? So our perpendicular slope would be -4/3. It's opposite reciprocals of each other. Okay, so now I have the point and I have the m is -4/3. So y minus 4 equal -4/3 times x minus 6. And if I do distributive property, and then moving that over, alrighty, that's what I get. That's the line that's tangent to the circle at that point. All right, let's see, the next part, completing the square. Write the equation in standard form by completing the square. So what we want to do is put all the x's together here. I'm going to say plus c. And then I'm going to do the y's together, all the y values. And I'm going to call that one d. I'm going to subtract the constant to the other side, and I have to add plus c plus d on this side, because whatever you do to one side, the equal sign, you have to do to the other. So now we're going to treat these as two separate things and find out what c is. Remember, c is equal to b divided by 2 squared. So in this case, half of 4 is 2, 2 squared is 4, so that's 4. On the one with the y, half of 6 is 3, 3 squared is 9. So on this side, I've got plus 4 and plus 9. So this would give me x plus 2 squared, because that's the factorization, the perfect square factorization. This would be y minus 3 squared. And let's see, what does that give us? 5. So that's our equation of the circle. So for example 6, they tell us that the diameter of the circle contains these 2 points. So first thing we need to do is find the center. So find the center of the circle. Center is exactly between these 2 points. So the center would be, let's see, 5 plus -3 divided by 2, and 5 plus -1 divided by 2. So that gives me 2 over 2, so that's 1. That would give me 4 over 2, which is 2. So that's my center. All right, so we know the center, and we need to find the distance of the radius, right? So the radius is the distance between the center and one of the points. So that would be 5 minus 1 squared plus 5 minus 2 squared. So 4 squared plus 3 squared. So radius is 5. Okay, so Now we have the stuff to make the equation. X minus 1 squared plus y minus 2 squared equal 25. Almost put 5. There we go, 25. There's the equation of the circle. Okay, so part B, find the equation of the tangent line at that point. So let's see, I have the center, which is 1, 2, and I have this point, so I got to find the slope. -3 over -4, so it's 3/4. And that means my perpendicular m would be -4/3. So m is -4/3, that's my point, so y minus -1 equal -4/3 times x minus -3. And then all I do is clean it up. And move the 1. There we go. All right, next sketch the circle and the tangent line. So let's do that. So we have our equation here. Our equation has the center at 1, 2. So 1, 2. Oops. Let me erase this a little bit. Okay, 1, 2. There's my center. The tangent line goes to the point -3, -1. All right, and the circle has a radius of 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, here's my circle. Oops. That little piece doesn't look very circle-y. Is that a word? Circle-y? Okay, and then the tangent line goes through that point. Slope is -4/3, so down 1, 2, 3, 4, right, 3. All right, so it goes like that. And voila! We know this is the radius and it's perpendicular there. Okay, example 7 is a challenging one. It says the circle contains these 3 points. Find the standard form of the circle by solving a system of 3 equations. So we know that for the standard form of the equation, we have x minus h squared plus y minus k squared equal to r squared. So what we're going to do is plug in what we know. It would be 0 minus h squared plus 0 minus k squared equal r squared. We also know 6 minus h squared plus 8 minus k squared is equal to r squared. And the last one is 7 minus h squared plus 7 minus k squared is equal to r squared. Okay, so these 3 are going to give us our equations. Now, on the first one, I know this gives me h squared plus k squared is equal to r squared. If I clean up this second one, that's going to give me 36 minus 12h plus h squared plus 64 minus 16k plus k squared equal r squared. And this last one, well, actually, let me clean this one up first. If I add my like terms together, that would give me 100 minus 12h minus 16k plus h squared plus k squared equal r squared. I don't know if that helps at all, but we probably are going to need to do it at some point. All right, then let's look at the last one. Okay, so the last one, if I clean that one up, that's 49 minus 14h plus h squared plus 49 minus 14k plus k squared equal r squared. All right, what I'm going to do is I'm going to set, well, first let me clean this one up too. Let me add my like terms. It's 98. It's only two things I can add together, but it just makes me feel better. Okay, so trying to figure out how to put these together. I see that these two are equal to r squared. Okay, so what I'm wanting you to notice, you see how this one's equal to r squared and this one's equal to r squared? I can set those two equal to each other. So that's what I'm going to do. So that's going to give me 100 minus 12h minus 16. Wish it would be a little bit neater. Minus 16k plus h squared plus k squared is equal to 49 minus 4. No, wait, I'm writing the wrong equation. Oh, shoot, hit the wrong thing. Darn it. Well, I wanted to erase this one now. Now it is. Okay. I didn't know it did that. Okay, I learned something new today. Okay, so this would be 98 minus 14h plus h squared minus 14k plus k squared. All right, so if I combine these like terms, I'm subtracting k squared on both sides, subtracting h squared on both sides, subtracting 98 on both sides. So actually, it cleans it up quite a bit. If I put the h's together, the k's together, I get 2 plus 2h minus 2k equals 0. And actually, I'm noticing if I divide everything here by 2, then I get that. So that means k is equal to 1 plus h. I'm hoping that helps. Okay, so I just added basically equation number 2, and I set that equal to equation number 3. Okay, that was my procedure there. All right, so what can we do next? Let's see, I'm going to change colors. Okay, I'm going to take the other two equations. I'm going to do equation number 2 and set that equal to equation number 1. So that's going to give me 100 minus 12h plus h squared minus 16k plus k squared equal to h squared plus k squared. The h squared and k squareds cancel out. So that leaves me with this. And if I use the fact that, I could probably simplify that too, but I didn't on my other notes, so I'm going to leave it. If I use the fact that k is equal to this and plug it in right here, let me go to a different color again. So this would be 100 minus 12h minus 16 times 1 plus h equals 0. So I'm going to sub it in right here, just so I can get one equation with one variable. And then I can combine my like terms and solve. And find out what h is. And I got 3. All right, so if h is 3, then I can plug it back into the other one. So k is equal to h plus 1. So k is 3 plus 1. So k is 4. So that means that's our center. 3, 4 is the center. So now I just need the radius And the radius, I can use any of the original points. I'm going to use the 0, 0 because why not? That's an easier one in the center. So that gives me 3 minus 0 squared plus 4 minus 0 squared. So that's the square root of 25. So it's 5. Alright, so my equation would be x minus 3 squared plus y minus 4 squared equal to 25.